Hey everybody, this is your third video for video notes. This one is going to be on basic matrix operations and an intro to multiplying matrices. I'm doing a video for this one because there's some things to write down that I don't want to spend a whole class period doing next week or this upcoming week, so I'll have you do it now to save time on notes in class. So while I'm doing this video, I would recommend pausing it, writing the things down, and then playing it and listening as I go. So make sure you're listening, it's not on mute, and make sure you're writing down all the notes. This is a reference for you, especially whenever we're in class if you need to look back on anything. So make sure you're not just watching and not writing anything down. And you may have to pause the video as we go because I already have everything pre-written. So pause whenever you need to get caught up with the notes. So basic matrix operations, again, a matrix, we've done this in class, we've written this before, but it's just a rectangular array of numbers in rows and columns. And the numbers in a matrix are called its elements. We'll be referring to the elements a lot. And again, the dimensions are rows by columns. We are going to say that two matrices are equal if their dimensions are the same. That's important here. And the corresponding elements are equal. Now, when I say corresponding elements, I mean like this here. The yellow elements are corresponding, the blue elements are corresponding, etc. They're elements that are in the same spot respectively, but in a different matrix. And adding and subtracting matrices, we've already had warm-ups on this, and you guys did very well on it. All you do is add and subtract elements in corresponding positions. Matrices can only be combined by adding or subtracting at least if they have the same dimensions. If they don't have the same dimensions, you can't add and subtract them. So just a review of adding, I'm going to add up the elements in corresponding elements, and I get my final matrix here whenever it's added. So take a minute and jot that down, because I'm going to move up here. Okay, scalar multiplication. We also had a warm-up on scalar multiplication. Scalar multiplication is when you multiply an entire matrix by a constant, like a real number. We're going to be doing this a lot whenever we do matrix operations. So scalar multiplication is pretty easy. All you do is you take your matrix and you distribute the 2 to every single term, and you get this matrix right here. You can also combine operations. Just be sure you follow those order of operations that you guys are already aware of. So if you have 3 times this matrix minus this matrix, you're going to want to take care of the 3 first and do that scalar multiplication, and you end up with this. Then you're going to subtract this matrix, and then you subtract your corresponding elements. So like 15 minus 6 is 9, negative 3 minus negative 2 is negative 1, etc. Whenever we do operations with matrices, the properties for a matrix are the same as the properties for real numbers. So the associative, the commutative, and the distributive properties all hold. Notice all of these have capital letters except for the constant. That's a K right there. It doesn't have to be capital. So the reason, again, we do capital letters is because a matrix is always designated with a capital letter. So you still can do associative, commutative, and distributive with matrices. So take a moment and get caught up to there. So pause the video if you need to before I slide up again. One thing you can do to get a little bit more difficult, so the stuff we've been doing so far is pretty easy. The next step is solving a little matrix equation, and these are kind of the entry-level equations. What they'll have is a couple matrices. They'll set expressions equal to each other, and they'll say solve for the variables inside the matrix. And what you do is you set corresponding elements equal to each other. Because you know that in a matrix, if 2 matrices are equal, the corresponding elements need to be equal. That fact will help you solve. So in this case here, I have 2 times 2 matrices added together. You could distribute the 2 to both matrices here, but I started inside the parentheses, and what I did is I added my 2 matrices together, and that got me this matrix right here. And notice the matrix I get here still has the variables in it. They're not going anywhere until I solve for them. So I did 2x and then negative 1, negative 3, and 4. I brought this matrix down. So now I have this expression is equal to this matrix. What I did next is I distributed the 2. I did the scalar multiplication. So I ended up with this matrix. So when you write that down, make sure you understand how I got it. I distributed the 2. Just be careful, when you distribute the 2 to this expression, it needs to go to the 2x and the 1 to get 4x minus 2. And when you multiply by this expression, it needs to go to the negative y and the 5, giving you this expression here. Now you end up with one matrix is equal to another matrix, and then the fact that corresponding elements are equal to each other really comes in hand, because I know that this is equal to this, so I set them equal to each other and solve for x, and I know that this is equal to this, so I set them equal to each other and I solve. And I know that I did this right because I end up with 2 equaling 2 on the top right and 16 equals 16 on the bottom left. So I end up getting x is 3 and y is negative 2. So take a second and make sure you're all caught up with that one there. I'll give you a couple like these to practice in class, but before you move on, I want you to try this one here, and I'll show you the answer in class. So I'd like you to solve this and get x and y. So again, start by distributing the 2, then subtract the 2 matrices, and then set corresponding elements equal to each other. And you should be able to get your x and y. So we'll check that in class Monday. So pause and make sure you have that written down. Take a minute and solve it before you move on, because we're going to start multiplying. Multiplying is significantly more difficult than the stuff we've been doing up here, because it's not just multiplying corresponding elements. You have to move across and move down. So this is section 3.6. Before it was 3.5. 3.6 is strictly multiplying. That's all it's in the section. When you multiply 2 matrices A and B, the dimensions of the new product are going to be the rows in the first matrix times the columns in the second matrix. So, for example, A times B. If A has dimensions 2 by 3 and B is 3 by 6, first of all, your inner dimensions need to be equal to each other. So 3 and 3 are equal, so I know I can multiply. I'm good to go. And then it's the outer 2 elements, so the one I circled in orange, those will be the dimensions of your new matrix, 2 by 6, so 2 rows and 6 columns. It'll look just like that. The rule for multiplying matrices that you'll see in the book is this right here. This might not make too much sense if you've completely forgotten multiplying, just because it's probably a bunch of letters here. But keep in mind, I'm going to say this a lot. Whenever you multiply, you always move across in the first matrix and you move down in the second matrix. So for example, what we do is, it's a combination of multiplying and then adding. So you'll do A times E plus, you move across here and move down here, B times G. Getting you that? What you do next is, since you already took care of the first column here with the first row, whoops, put that A back. Hold on. Come back. There we go. What you do next is you stay in the first row, but now we're going to take care of the second column. So A times F plus, move across here to B, move down here to H, B times H, giving you this. At that point, your first row is completely done, so let's move to the second row. Second row, first column, C times E plus D times G, and then C times F plus D times H. So write that down. It'll make a little bit more sense once we actually do an example with it. Just remember, move across the first matrix, move down the second matrix. So I have an example here of a matrix A and B. We're going to find A times B, and then we're going to find B times A. So right here, write these 2 matrices down. I would pause once we've written them down so you can watch how we do this here. There's a lot of writing on here, but it's color-coded for how we do it. So I'm going to start, and one thing that can help if sometimes people get a little lost whenever they do matrix multiplication because there's so much going on. First of all, these are both 2 by 2s, so no matter how I multiply them, the outer dimensions, the outer numbers will be 2 and 2, so my product will be 2 by 2, whether you do A times B or B times A. So I'm going to start on the left here and on the top here. Let's do blue first. So the blue pen goes with the blue highlighter. I'm going to move across here and down here. I'm in row 1 and I'm in column 1. And that's going to correspond with the element that's row 1. That's a 1, believe it or not. Column 1. So I do 1 times 5 plus 4 times 9. to get this element is in row 1 still, but it's in column 2. So my first matrix gives me my row information. My second matrix gives me my column information. Because I'm in row 1, I'm going to go across row 1. Because I'm in column 2, I'll go down column 2 now. So 1 times negative 7 plus, move across, move down, 4 times 6. Now I'm down here. This element is in row 2 now, but it's column 1. So row 2, column 1. So 3 times 5 plus negative 2 times 9. And our last element is in row 2, column 2. So I'm still in row 2 now. Now I'm in column 2. 3 times negative 7, move across, move down, plus negative 2 times 6. I'm doing a very similar procedure here, moving across, moving down this one. And whenever I do B times A, you can write that down and try to follow along with it, I end up getting this. Notice these two matrices are not the same. That's because matrix multiplication is not commutative. A times B will usually not equal B times A, not commutative. Whenever A times B does equal B times A, there's a special property associated with it, and we'll talk about that later on this week whenever we look at it more in depth. I'm going to do one more example with you here. And let's see here. I'm going to multiply this matrix by this matrix here. And let me get rid of this thing here. Go away. So I'm going to multiply. And I'm going to start by thinking, okay, to get this element here, this is row 1, column 1. So I should be in row 1, column 1. And I'm going to multiply. Start at the left, start at the top. Negative 1 times negative 3 is 3, plus 3 times negative 4 is negative 12. 3 plus negative 12 is negative 9. What I'm going to do next is try and get this element here. This is row 1, column 2. So I'm going to be in row 1, column 2. So move across, move down. Negative 1 times 2 is negative 2. Plus 3 times 1 is 3, and I get 1. Next, I want this one here. That matrix, or sorry, that element is row 2, column 1. So I want to be in row 2, column 1. So now I have, start at the left, start at the top. 4 times negative 3 is negative 12, plus negative 2 times negative 4 is 8. Negative 12 plus 8 is negative 4. Alright, so I cleaned up the matrices a little bit. I want this element, now this is row 2, column 2. So I'm going to be in row 2 here, column 2 here. Remember, the first matrix gives you row info, second matrix gives you column info. So I'm going to do 4 times 2, which is 8, plus negative 2 times 1, which is negative 2, giving me 6. And let's see, 2 more here. Let's use orange. Now I want this guy here. This is row 3, column 1. Row 3, column 1. And let's go ahead and multiply. So what I'm looking at is 5 times negative 3 is negative 15, plus 0 times negative 4 is 0. Negative 15. And last, I want this element here. This is row 3, column 2. So I should go row 3 here, column 2 here. And we're going to move across and move down. Start at the left, start at the top. 5 times 2 is 10, plus 0 times 1 is 0. 10 plus 0 is 10. So here's my final product. Notice that I could not have switched the order, because then that would have been a 2 by 2 times a 3 by 2, and the inner dimensions wouldn't be the same, so you could not have switched the order. One other problem I want you to do before you come to class on Monday is to multiply these two matrices together. So I got it kind of started for you here. I have a 2 by 3 by 3 by 3. These two are the same, so we're good to go. My outer two matrices tell me the dimensions of my new matrix. There should be 2 rows, 3 columns. So remember, you move across here and move down here. Just keep in mind, always look at your final elements here. So for example, to get this one here, this is row 2, column 2. So you should be using row 2, column 2 to get it. So when I multiply matrices, I always start with row 1, and I stay in row 1, and I stay there until I've gone across and gone down and used all my columns. Then I go to row 2 and then go down. Okay? So let me get rid of all that scribble I just did. Oh, shoot. So try multiplying those two, and then in class we'll practice in the notebooks and with whiteboards. Have a great weekend.